Hey guys, welcome back to AlgoYogi. We are doing stack series, and our next problem in the list is remove all adjacent duplicates in string second. Let's go to LeetCode and give this problem a read. You are given a string s and an integer k. A k duplicate remove consists of choosing k adjacent and equal letters from s and removing them, causing the left and right side of that deleted string to basically again concatenate them together. We repeatedly make k duplicate removals on s until we no longer can see. Return the final string after all such duplicate removal have been made. It is guaranteed that the answer will be unique. Alright, so problem statement is clear, but let's understand it again in detail. So this is the string that's given to us, string s. Then there is a value of k that's given to us, that is, in this case k is 3. Let's say in this example k is 3. Now we need to perform some k adjacent same letters removals. Let's see what does that mean. It means we need to choose at a time k is 3, so 3 same digits and remove them, and we keep doing it. So these are not same, by the way, these are same. Keep doing it until we no longer see these k number of same alphabets or letters, strings, whatever. So in this case, if you see, we see triple E right here. This is the triple E that we can remove, and after removing these we can again join the left substring, remaining substring, and right remaining substring. So that's one way of doing it, but let's delete all the occurrences in one go. Whatever you see that has count 3, then we see over here C also occurs 3 times, which is k. So after we remove all of those, we get D, B, 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 D, A, A. But this is not where it ends. Now we're gonna check again if there is something, there are some k number of characters that are same and equal, adjacent k number of characters. So, but we see here again this B, B, B 3 times is occurring over here. So we will delete this. Then again we get D, D, B, sorry, B is gone, but again D, A, A. Alright, so, but again we will perform the same thing. We see triple D over here. After deleting those, we get AA. So that is our final string, but you cannot see any more k number of same strings to remove from AA. So that is our final answer. So let's see how we're going to do that using stack. So here there are 2 things that we need to check. First is we need to see the character, and then we need to see the count of that character, and that too adjacent basically. So how about we traverse our string from left to right, and in our stack we basically store 2 values. First is the character, and then the count. Okay, so what I mean is I will go from left to right, iterating my string. Then I will store in my stack the character over here. So CH character, and then COUNT count over here of that character adjacent basically. So if I'm seeing D over here, so what I'll do is I'll append D, and I'm seeing it 1 number of time, so I'll append D. Then I see E right over here, so I'll append E, then 1 number of time. Then I see again E. So I'm not gonna append E again, but just update the count over here. Then E, I'll update the count over here. Then in my while loop or for loop, I will keep a check that whenever my stack stop basically second, which is this value. So let's say this is stored at 1. If this is equals to k, if this is equals to k, if this condition passes, then I will remove this from my stack. So I will pop this. So I will do stack dot pop. So this will basically, I will remove it from my stack. So I will remove e and its count from here, right? Then I'll continue basically going over my string. So in this case, what will really happen is, whenever you see a same string later and then its top already has that particular key, you can say key in this case. So what I'll do is I will append the instead of appending it as a new character, I will basically increment its count. So right now I'm here right now. So I see D is already present on top of my stack. I only care about the top of my stack because that's where we will see the same string, right? That's where I need to basically take an action, otherwise I can keep trading my string. So I see D, so I will increment its count. Then I see B is not on the top of my stack, so I will add B and then 1. Then again C, okay, I see again I see B, and then again I see one more B, so I'll append 2 here. Then I see a C, 1, second C, 2, third C, so 3. So what I do, I will remove this because now this condition passes, so I have to remove this 3 from here. So I will remove this C and its count. Then I again go to B, but if you see, I check the top of my stack. In the top of my stack, I see B is already on top, so I will increment its count. And then again you will see I will basically pop this from the stack because its count is equal to k now. So I will remove this B as well. Then I'm here at D, I will increment D here because it's on top of my stack. Then I will also again pop this. So see how this becomes really easy now. Then I am at A, I'll append A and increment 1, then A, then 2. Finally I have this left in my stack. I will basically go over my stack and then create the result string basically by multiplying the character with its count and keep appending it to result. Okay, so keep doing it for everything in the result and then return that. This will be of big of n time complexity, and same for space and space complexity, space and time. Okay, I guess that was all of it. Let's write down our solution. It will be easy peasy. Looks pretty good. So as I said, we'll have a stack. Then we are going to go over all the C in my S. I'm gonna check if there is some value in my stack and stack stop. That's how you access the stack stop. Stack stops value at the second index, which is this. If that, sorry, the first index, if this is equals to C, that means I will increment its count because it's already on the top of the stack. I just need to increment its count. So stack stop at the first index, let's increment it by 1. That's it. Okay, so I have incremented that value by 1. Then I will now, if else I will append it. So either I see the same value on the top, or I will append that as to my stack. Basically I will append to stack dot append. We are going to append 2 values. First is character and then second its count as 1. Now there is one more thing that we need to do is now one of these conditions will execute, but another thing is if I see that my top of my stack's count, top of my stack second value is count, which is at index 1, is equals to k, then I will pop stack.pop. So that means I'm popping that value from the stack. So that will go over all the strings. If it has seen the string on the top already, then it will basically increment its count, which is as this first index, and otherwise it will append that character to the top of the stack and add 1 as count, because that's the first time it's seeing that string. Now we are out of the loop. So I will go over my stack. I will create a result string. So result is initially empty, then for let's say ch for I in range length stack, or I could just say could I access item? Yes, for item in stack, result plus equals to item second value, which is the count, into item's first value, which is the string. So that many times you have to create that string first. Let's say if a, and in this case it was a and twice it was on the top of the stack, then 2 into a, so 2a we will append to my result, then I will return that result. Okay, so that is it. I will run it on the example cases and see if this passes. It does. Let's submit our answer. Awesome. It's a good efficient solution. Let's write down the time complexity. Time complexity is big of n. Space complexity is big of n as well, because our stack. And that is it. Let's go to LeetCode, mark this solved, and see you guys later in the next problem. Until then, bye bye.